comes the, here comes the, here comes the. Y'all don't really want it like
Calculus. So, Evan, what is the first derivative test?
Great question, Derek. The short answer would be to find the relative extrema on a function. To do this, first you must take the derivative of the function, set that equal to 0, and solve for x. Those x values are known as critical numbers. Now with these critical numbers, you set up intervals and test points in those intervals to get the sign for f of x. If the derivative changes signs, then you know there is a relative extrema at that critical number. If the derivative goes from negative to positive, then that means there is a relative minimum at that point. And if the derivative goes from positive to negative, then there is a relative maximum at that critical number. Now, let's try another example. Let's try an easy one to start out. Let f of x equal x squared minus 6x. We need to find the intervals where f is increasing and where f is decreasing, and locate the relative extrema. Please pause video now. Alright, let's go over it now. First, take the derivative of f of x. You should get 2x minus 6. Next, set that equal to 0 to get the critical numbers. Our only critical number for this problem is x equals 3. Now that we know the critical number is 3, we need to make intervals around that critical number. The intervals for this problem will be negative infinity to 3, open interval, and 3 to infinity. Next, pick test numbers in these intervals and then plug them back into f prime of x to get the sign of f prime of x. And if there's a change, then you know there's a relative extrema. For my test numbers, I chose x equals 0 and x equals 4. First, you plug in x equals 0 to f prime of x, and you get 0 minus 6, which is negative 6. So that's negative. Then you try x equals 4, and you get 8 minus 6, which is positive. So since it changes from negative to positive, you know there's a relative minimum at x equals 3. Alright, let's try another one now. This one's a little harder than the other one, but still pretty easy. Let f of x equal x to the 5th minus 5x all over 5. Do the same directions as you did for the last one by finding the intervals where f is increasing and f is decreasing, as well as finding the relative extrema. Please pause the video and try the problem by yourself. Alright, time to see if you guys got this one right. F prime is increasing on the open interval from negative infinity to negative 1, and the open interval from 1 to infinity. It's decreasing on the open interval from negative 1 to 1, and it has a relative maximum at the point negative 1 comma 4/5, and has a relative minimum at the point 1 comma negative 4/5. Good job if you got that one right, but if you didn't, don't worry, because I'm going to go over the solution path really quick. Alright, you start off again by taking the derivative of f of x to get 5x to the 4th minus 5 all over 5 by using the quotient rule. Then that simplifies out to x to the 4th minus 1. Then you set that equal to 0 and solve for x to get you the critical numbers. Next, you got to set up your intervals around your critical numbers. So the intervals would be negative infinity to negative 1, negative 1 to 1, and 1 to infinity, all open intervaled. Next, choose your test numbers. I chose negative 2, 0, and 2, but you can choose any one you want as long as it's in the interval. Next, plug your test numbers back into f prime of x so you can see whether f is increasing or decreasing on that interval. Now you are able to tell which critical number is a maximum and which one is a minimum. This lets you know where the actual maximum and minimums occur, but to get the actual value for the maximum and minimum, you have to plug it back into f of x and get the y value for it. After you do that, you just put the x and y values together and put it with the minimum or maximum next to it, and then you're done. Now we finish up section 3.3 on first derivative test. Now it's time to move on to section 3.4, which is second derivative test. The second derivative test is what you use to determine concavity of a function, as well as to find inflection points. The second derivative test is really similar to the first derivative test, except For this, you need to find the second derivative of a function. After you do this, just follow the same process as what you did for the first derivative test. Just set f double prime of x equal to 0 and solve for x to get your critical numbers. These are all possible points of inflection. Then, set up intervals around the critical numbers and choose test numbers from those intervals to plug back into f double prime of x to test for concavity. If one interval is concave down and the next is concave up, or vice versa, the critical number in between is the point of inflection. Since these problems take longer, we will do only one example for this. For this problem, we need to find all relative extrema using the second derivative test for the function 6x minus x squared. Alright, the first thing you do, just like in the first derivative test, is set f prime of x equal to 0 to get the critical numbers. In this, you have 6 minus 2x is equal to 0, so you solve for x and get x equals 3. The next thing you're going to do is take the second derivative and plug that critical number you just found into the second derivative to test for concavity. When you plug 3 into f double prime of x, you get negative 2, which is concave down. Since it is concave down, we know x equals 3 is where the relative maximum is located. Finally, just plug 3 back into f of x to get the actual y value for the maximum, and then you're done.